Hello and welcome to week 3 of our Math 9 afternoon class. Today, what we are going to be doing is we're going to be going over everything that we learned in this transformations unit. So it's just a nice little review, and then there's a package that goes over all the things we talk about today. So if you remember a long time ago, we started off the unit by just plotting some points, and we started by talking about Cartesian planes. A Cartesian plane just means an XY grid, like what we have here. This thing over here is a Cartesian plane. And the way that we plotted points is by remembering what an ordered pair was. So an ordered pair always went bracket and then a number and then comma and another number and then a bracket, where the first number was X, the second number was Y. That means X told you how far left or right to go, and Y told you how far up or down to go. Okay, just some simple reminders here. Negative numbers. Negative numbers go left and down. Positive numbers go right and up. Oh boy, sorry. Wonderful. So let's try plotting some points. So this first question says plot the points on the Cartesian plane below. We have 1, 3. For graphing, we always start right in the middle, right at the center of our graph. The first number tells me if I'm going left or right. Because it's positive, I'm going 1 right. So I'm going to go 1 to the right. And then the next number tells me up or down. Because it's positive, that means 3 up. So I would then go 3 up. 1, 2, 3. And my first point would be right there. We call that point 1, 3. All right, we'll try B. So we're graphing the point -2, 4. -2 tells me because it's negative, I go 2 left. The 4 tells me because it's positive that I go 4 up. Always start at the center where my green dot is. I go 2 left, 1, 2, and then 4 up. 1, 2, 3, 4. So that spot right there. We call that point -2, 4. Awesome. You can try the next two on your own. If you look at C, C is -3, -5. That means 3 left, 5 down. So it would be right here. -3, -5. And if we looked at our last one, 0, 2, 0 means you don't go left or right, and -2 goes down 2. 0, -2. And those are my points plotted on my Cartesian plane. Wonderful. If we look at 2, it says translate 5 left, 4 down. So translate means like move it, just like slide it. So we're going to slide it 5 to the left and 4 down. We slide the corners. So I'm going to take this corner right here. I'm going to move it 5 left, 1, 2, 3, 4, 5, and then 4 down. 1, 2, 3, 4. So after moving that corner 5 to the left and 4 down, the corner of that shape is now right there. And I'm going to do the same thing with the other corners on the shape. So I'm going to take this corner and I'm going to go 5 left, 1, 2, 3, 4, 5. I'm going to go 4 down, 1, 2, 3, 4. And that corner is now moved to there. The other two corners of the shapes, I'm going to take this one right here, 5 left. 1, 2, 3, 4, 5. 4 down. 1, 2, 3, 4. And the last corner, this one right here. 5 left. 1, 2, 3, 4, 5. 4 down. 1, 2, 3, 4. And once I've moved the corners, all I need to do from that point is connect the dots. So if I wanted to connect these dots, it would give me my shape. And you'll notice that my new shape looks the exact same as my old shape. It's just been moved over and down. It's important to recognize that when translating, the shape doesn't change. It should be the same size, same angles, just in a new spot. Wonderful. If you want to try B on your own, I would do all those corners. So there's a lot of them. You're going to transfer it 4 to the right and then 4 up. And I'll let you try that on your own. Awesome. Hopefully you did. You paused it and you tried it on your own. I'm going to start moving points. I'm just going to start with this one right here. So I'm going to go 4 to the right. 1, 2, 3, 4. And then 4 up. 1, 2, 3, 4. It goes right there. I'm then going to move the point below it. This one. 4 to the right. 1, 2, 3, 4. 4 up. 1, 2, 3, 4. And it should go right there. Sometimes it actually helps to connect the dots as you're building it. So if you want, it might not be a bad idea to connect those dots so that you know you have that side built now. If you do the rest of these, I'm going to try to go decently quick here. So I would take this green right here. It would go 4 right and 4 up to that spot. I'm going to take this guy right here, orange. 4 right, 4 up. It's going to be right here. I'm going to take this one light blue. 4 to the right and 4 up should be right here. I'm going to take this one over here. 4 right, 4 up should go right there. We have a few left. I'm just going to do all of them in yellow. If you moved all those 4 to the right and 4 up, they should go right here. And then again, you connect the dots to make your shape. Like that. And you'll notice my shape is the exact same as the shape that I started with down here. You can see me drawing it. It looks the exact same. Nothing's changed. It's just moved. And that's what translating is. It's moving a shape. It's not changing the way that it actually looks. Beautiful. Hopefully you did a great job on translating. That was usually one of our easier ones. Okay, we're going to move forward now, and we're going to try reflecting. So reflecting, if you don't remember, reflecting is like a mirrored image. So what we want to do is like fold it over to the other side. This one says reflect about the x-axis. So the first thing I'm going to do is I'm going to draw a line where my x-axis is. This blue line is my x-axis. My job is to somehow take this shape and I want to reflect it to the other side of the x-axis. Create like a mirrored image. And again, the way we do that is by moving each point. And when we move a point and we mirror it, you're going to figure out how far away that point is from the line that you're mirroring. So if you look, this point right here is 1 away from my line where I need to mirror it. That means that I need to make it 1 away on the other side of the mirror, like that. And we can keep doing that with points. So this one right here is 1, 2 away. That means my mirrored point should be 1, 2 away. It should go right there. We do that with our last couple points here. So I'm going to do one in green. I'll go purples. This purple one up here is 1, 2, 3, 4 away from my mirror. That means the image should be 1, 2, 3, 4 away from my mirror, but on the other side. My last one, this guy up here, is also 1, 2, 3, 4 away. So 1, 2, 3, 4 away. It should go right there. And then you connect the dots. So for connect the dots on this thing, my image should now look like this. And you'll notice it's the same image. It's just like it's been folded over to the other side. It's a mirror image. The lengths of each side of the shape haven't changed. The angles haven't changed. It's just mirrored. If you had that on a piece of paper and you folded it over, that's exactly what it would look like on the other side of our x-axis. If you want to try B by yourself, I welcome you to go ahead and make sure you read these questions though, because this question is being reflected about the y-axis. That means you need to flip it onto the other side of this. Where the other question wanted you to flip it to the other side of the x-axis. So for us, it's a little different. I want to go from here, I want to flip it over to that side. The other side of the y-axis. Again, do it corner by corner. That's my best suggestion. So give it a shot, pause this video, see if you can reflect it, and then I'm going to draw the answer, and you'll see if yours are all at the same point. Okay, hopefully you have paused and tried that. I'm going to take this point, and I'm going to move it first. So the way I reflect it to the other side of a mirror is I figure out how far away I am from the mirror. So I'm 1, 2 away. That means I need to be 1, 2 away on the other side of the mirror. I'm going to do the point below. The point below in orange here is 1, 2 away. That means I need to be 1, 2 away. And it might be smart to start connecting your dots early, especially with a trickier one like this, in which there's lots of corners, right? So you might want to be like, okay, I know those two lines connect. And then from orange, I'm going to go to green right here. Green happens to be 1, 2, 3 away. That means I need to go 1, 2, 3 away to this spot right here. And it might be wise to connect the dots right now while I can. Then I'm just going to keep doing points. Okay, I'm going to go a little quicker now. So if you were lost, maybe you could rewind or check my other notes so you can be like, oh yeah, I remember that. This light blue dot, we go right here. It's 3 away. This black dot over here would be 5 away, so we'd go all the way over here. This, I don't know, weird color one over here would be 5 away, so it'd be over here. And then I'm going to do a bunch of yellows again for this top. So 1, 2, 3, 4. You figure out how far away they are. And it'd be 1, 2, 3, 4. And hopefully you're connecting the dots while you do this. So green connected to blue, blue to black, black to that weird color to yellow, the 4 yellows all connected to make a little box, and then yellow connected to purple. And you'll notice we still have the same shape. It's just been mirrored over. It's like folded to the other side of the y-axis. Awesome. Hopefully you remember doing reflections. Rotations. Rotations is going to be very challenging for us to do right now. Because remember, this is what we did with a piece of paper. So if you want to do a reflection, what you want to do is you want to take a piece of paper and you want to trace it on top of your picture. Then you want to put your finger or a pencil to hold the paper right in the middle, and you want to spin your paper around. The way you decide how to spin your paper is in the question. This one says 90 degrees clockwise. So 90 degrees means 1 quadrant. Clockwise means this direction, like if you're reading a clock. So this image needs to go one quadrant this way. So it should be somewhere in here. To do that, you take a piece of paper, you put it on top of your picture, you trace your picture, then you put your pencil right in the middle, right here, right where this big red dot is. Put your pencil right on that spot, and you spin your paper one quadrant so it's over here. Remember we did this in class? It's going to be very tricky because I can't really demonstrate it for you on a laptop because I don't have a piece of paper that you could actually see. That makes it kind of hard. Another way we rotate images, because there is another way. There's more of like a mathy way. The mathy way to do it is to take a point. Let's take this point, for instance. That is at 1, 1. When I rotate it 1 down, it should still be at 1, 1, except now it's 1, -1. The numbers should be the same, but your symbol is going to change. Now that one's an easy one because both the numbers are 1, right? If you look at another one, let's look at this guy, the green dot I'm doing at the top. That one is at 1, 4. All right, that's a trickier one because the numbers are different. So the way that we're going to do this is when you rotate it, you are going to rotate the numbers. So the 1 and the 4 are going to switch. So now you're going to be at 4, 1. And instead of it being 1, it's -1. The y value changed because I'm down here, so I know it's going to be a negative y value. That means that point is now at 4, -1. It's right there. It's tricky. I know. The mathy way is tricky. That's why we usually do the paper way. But if you're having trouble with your paper, you don't have a paper, don't remember how to do the paper, then you need to remember the mathy way. Let's look at another point. This blue one right here. Blue right here. That blue point is currently at 3, 2. Right? It went 3 to the right, 2 up. If I wanted to rotate it 90 degrees clockwise, the 3 and the 2 change. So this now becomes 2, 3. And because I'm now down 1, that makes it -3. So that point went from 3, 2 to 2, -3 right here. My last one is 4 and 4. 4 and 4, if you rotated it, would still be 4 and 4. So it's an easy one. The second 4 became negative because I went down 1 quadrant. So the last point is 4, -4, right there. So after you rotated this image, whether you used my way with like the kind of mathy way or the paper way where you traced it, you should have got those 4 corners transferring to those 4 points. And then if you connect the dots, it should look like this. And you'll notice it's the same image, except it's just kind of been rotated around. It looks kind of the same. It's just been spun a bit. These are definitely the hardest things that we did, the rotating. Especially it's going to be harder without being able to have the paper. If you want, like, you could try maybe Googling some things on how to rotate with paper, with tracing paper, but there's not many good demonstrations out there. I've tried looking to see if I could pass one along to you. And I don't have the ability to really show you well with paper. So either we're going to have to kind of remember what we did before, or you're going to have to try the points and changing the points, change the X and the Y values. All right. Look at B. We could do the same thing. So we could take corners. Well, let's talk through the tracing paper one again. So if I put my paper on top, what I would trace is I would put my paper on top and I would trace this image on my tracing paper. I would also trace the X and the Y axis because that tells me if I've turned it too far or not. I then put my pencil right on the middle and I spin my paper 90 degrees counterclockwise. So 90 degrees means one quadrant. Counterclockwise means like this. So I'm going to spin my paper with my pencil right on the middle of my paper so that this image goes counterclockwise one to the right. If you're spinning your X and your Y axes, that means my axes should all be switching one over. So this one is now up here. This top one is now down here. This one is now over here, like that. And then I would just copy the image, redraw it out, but on my new quadrant. If you can't do that way with the paper, what you could do is you could take each corner, a corner like this, -2, -3, and you would change it so that it now becomes -3, -2. But because I went to the right, my X values are no longer negative, my X values are positive. So that blue point would now be at 3, -2. It would be right here. And you could do that for multiple points, like all the corners over here. I'll do the purple one, this one right here. That purple point is currently at -2, -5. Because I'm rotating only one quadrant, the numbers change to be -5 and then -2. And because I went into this quadrant, I know my X values are not negative over there. So it's actually 5, -2. So it's right here. And you do that to all those points, and then you can draw your shape. We'll do a few more just so you can kind of see. This light blue, this light blue one should rotate to be right here. And it might be wise to even, if you're doing it this way, connect the dots as you go. Otherwise, it gets kind of confusing. This green dot right here. Sorry, I keep forgetting to change. This green dot right here is currently at -3, -4. So it should switch to be 4, -3 right there. And we should connect the dots just to kind of help us keep it organized. My next one over here, the purple one. That purple one should change from -5, -4 to be +4, -5 over here. And then again, connect the dots. You then should go 1 over to here. You should go 1 up to here. And then I believe it's 1 out, 1 out, 1 out, 1 up like that. And that's hopefully what your image looks like. And again, you notice it's the same shape. The lengths haven't changed. The angles haven't changed. It's just been spun around. I understand if it's hard to do these spinning ones, especially without a good demonstration on what the paper looks like. You could do either method. You could use a piece of tracing paper, or you could use my way of switching the XY coordinates. Awesome. We're going to name some shapes. And then after we're done naming shapes, we are going to do some scaling. So we're going to name these polygons. Polygons just mean shapes. So if you're looking at this word up here and you're like, what the heck does polygon mean? That just means shapes. We name regular polygons, which means that the lengths are the same and the angles are the same. So if you look at this first image, like every single side length is the same length. It's called a regular polygon, a regular shape. We're going to name all these shapes we see here. The way we name shapes is by how many sides there are. So in this first one, there's 1, 2, 3, 4, 5, 6, 7 sides. That is called a heptagon. If we look at this one right here, it's 1, 2, 3, 4, 5 sides. That is called a pentagon. We look over here, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That is a hendecagon. Look over here. We have 1, 2, 3, 4, 5, 6 sides. That's called a hexagon. I had to think about that one for a second. Back down here, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's called a decagon. We look at this next one. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That is a dodecagon. I'm going fast. So remember, you can pause and rewind and look at them again if you want. If we look at the next one, 1, 2, 3, 4, 5, 6, 7, 8. My favorite one is an octagon. 8 sides, 8 arms like an octopus. And my last one, 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 is like a nonagon. Wonderful. You are going to have to name shapes, so like just practice them. Those are the ones you're going to have to do. You're going to have to do from 5 sides to 12 sides. Beautiful. The next thing we did was we classified triangles, or we named triangles. Same idea. We named them. We named them based on 2 things. We named them based on their sides and based on their angles. So if we look at this first image, to name it based on its sides, I need to realize that all these sides are different lengths. Right? None of them are the same. When none of them are the same, we call that a scalene triangle. The sides are all different. To name this based on angles, first thing I notice is right there, I have a right angle or 90-degree turn. So it's like a perfect corner. When you have a perfect corner like that, a 90-degree angle, we call that a right angle triangle. So that's a right angle triangle. I should probably put angle. Perfect. If we look over here, the first thing we do is we're going to name these sides name this triangle based on the sides. You'll notice that all the sides are the exact same. So we call that an equilateral. All the same. If I want to name this based on angles, the first thing I want to do is check to see if I have a 90. I don't. All of my things are less than 90 degrees. They're all smaller. They're closed off more. So because the angle's closed more, all of these angles are called acute because they're smaller than. So this would be an acute angle triangle. Because all angles less than 90 degrees. If we look here, if I want to name this triangle based on the sides, I want to first realize that those 2 sides are the same, but this side is different. This is called an isosceles triangle. There's no E on the end of isosceles. So isosceles is 2 sides the same, but the third one is different. If you look at the angles, the first thing I check is, do I have a 90-degree angle, like a perfect corner anywhere? And I don't. I have a little angle here and a little angle here. Those are both acute. They're small. But then I have a big angle here. That's bigger than 90 degrees. See how it opens up the triangle more? When you have that, we call that an obtuse angle triangle. And you only need one big angle for that and 2 small. Perfect. So those are all our names. We have scalene, equilateral, isosceles for naming by side length, and then we have right, acute, and obtuse. I want you to try to name number 4 on your own. So pause, come back, and see if you can name it. Hopefully you did that. If you look at the side lengths, these two are the same. This one's different. So because 2 are the same, it's isosceles. Then I'm going to look at the angles. First thing I recognize is, oh, that's a perfect angle right there. So we call that a right angle triangle. Wonderful. The last thing that we did is scaling. So that's taking images. So scaling is making the images bigger or smaller. We did that by using ratios. This is a ratio. So a ratio, I'm just going to spell that a little nicer for you. A ratio is two numbers being compared to each other, and we use a colon in between the numbers. So that's 1:15. A ratio tells you if something's getting bigger or something's getting smaller. So to read a ratio, you need to realize what each number means. The first number is what your new length is going to be after you've made it bigger or smaller. Your second number is what it actually is. So for this, what it means is that if I was to take something and scale it with this ratio of 1:15, that means for every 15 that I had, I now only have 1. That means I'm making it smaller. This would be, let's say these are centimeters. So this would be 1 centimeter for every actual 15 centimeters. And I'm just making up centimeters. It didn't say centimeters. It could have been 1 meter for every 15 meters. Could have been 1 foot for every 15 feet. As long as we understand that it's getting smaller, right? I'm drawing less for every 15 that I used to have. If I look at my second ratio down here, this means that for every 2, I'm going to draw 3. So I'm going to draw 3 centimeters or make 3 centimeters for every actual 2 centimeters. That means this image is getting bigger. The way we see this, we see it a lot with maps, also scaling like cars, houses, apartment buildings, stuff like that. Let's read the first question. It says, Mr. Kennedy draws a map of H.J. Cody using a scale of 1 centimeter to 100 centimeters. That means that for every 100 centimeters something is in real life, I'm only going to draw 1 centimeter on my map. Question A, if the upstairs hallway measures 20 centimeters long on the map, how long is the actual hallway? Here's the trick. So if I'm looking for the actual hallway, I put the question mark on top. That's what I'm looking for. And then I divide it by whatever I was told. In this case, I was told that in my drawing, it's going to be 20 centimeters, right? 20 centimeters on the map. That's going to be equal to my ratio. My ratio is 1 drawing for every 100 actual. So if I look at this first fraction, I did actual divided by drawing. That means my ratio should now be written as actual, which was 100, divided by 1 for drawing. To be able to figure out actual size lengths or drawing size lengths, you have to use ratios like this and then do some multiplication. Whatever number's on the bottom, we need to multiply to the other side. This means my question mark that I'm looking for, the actual length, equals 100 times 20 divided by 1. If you put that in my calculator, that means the actual length of my hallway, or what I was looking for, equals 2,000. That's the actual length of my hallway. If I look at B, it says, if Mr. Kennedy's classroom measures 850 centimeters, how long should it be on a map? This time, I'm looking for how long should the drawing be. But no matter what, I always put that on the top of my fraction. And then I divide it by whatever they gave me. They said my classroom measures 850. That's the actual measurement. So this is draw divided by actual. That means I need to make it equal to and use that same format, but using my ratio. So I want to do my drawing divided by my actual. So 1 to 100. The drawing is 1 centimeter. The actual is 100 centimeters. Once I have my ratio set up, I just take the bottom number and I multiply it up here. This gives me question mark equals 1 times 850 divided by 100. If I put that in my calculator, 1 times 850 divided by 100 would be 8.5 centimeters. Wonderful. Number 10, drawing a car. I want you to try this on your own, and then I'm going to go through it pretty quick. So pause, try it on your own, see if you get the right answer. Okay, hopefully you did that. To set this question up, it says, while designing a car, Honda creates a clay model using a scale of 2 centimeters to every 15 centimeters. If the car is a total of 800 centimeters long, how long should it be on the model? So I'm looking for model on top divided by the 800 that it actually is. That's model divided by actual. So that should equal whatever my ratio was, but I draw the model on top, so 2 on top, divided by the actual, which is 15. I do my multiplication, so I take 800 and I multiply it up here. That means my question mark equals 2 times 800 divided by 15. You throw that in your calculator. 2 times 800 is 1600. Divide 1600 by 15, and you get 106.6 repeated. So the model should be 106.6 centimeters long. It's a pretty big model, but I mean, you're doing a car, so it kind of makes sense. Wonderful. Part B. If I was to do part B, first thing I do is I set up my fraction. So it says, if on the model the door is 26 centimeters long, how long is the door in real life? So I'm looking for the real life. I divide it by my model. So this is actual divided by model. We should make that equal to whatever my ratio was, but putting actual on top this time. So 15's on top divided by 2. If I multiply this up here times 26, that means my question mark equals 15 times 26 divided by 2. If you put that in your calculator, 15 times 26 is 390. Divide that by 2, and you get 195. That's the length of my door in real life, 195 centimeters. Perfect. Hopefully you enjoyed your review lesson. Good luck on your practice sheets. Take care of yourselves. I will see you hopefully soon.